Yeah, time for another DraftScience video presentation. So for those who have been following along, this will be a bit redundant. Apparently you have to really actually put it in diaper form. You know, you have to give them the Pampers version of physics because people are so stupid. And they're such lying fanatics. And this comes down to just lying now. Clearly, they have no evidence for what they're saying. They're making assertions as if it's true, and there's zero evidence. They can't show a single experiment demonstrating what they're saying is true. Or I can show experiment after experiment after experiment demonstrating certain facts that just can't be disputed. So let's again just go through it one more time for the morons like Pyrrho. Okay, you can't follow along at all. So tons of experiments doing this very thing. So the two examples are you can have a train that's actually moving, okay, and you just connect it to another train that's not moving. All right, and the two trains have the same mass. So you're just going to double the mass, so it's 5. Then this one's the connected train, dot, we just have little dots here. We're going to connect the two trains together, then it's going to become 10. And the velocity is going to start at 10 and it's going to become 5. Now the other version of this experiment, just Velcro, stick them together. Trains have couples on them, so you can understand this has sort of been done in real life, but it won't be done as efficiently as it can be done synthetically. But the other version of this very same experiment, which I can find maybe 50 videos showing, at least 50, you start off with the train going a velocity 10, a 5 train, and then you just drop a brick on it. Okay, you just drop a 5 whatever unit brick. Okay, so this is whatever the units are of mass. So you just double the mass, and then the train leaves at 5 velocity. Okay, the velocity cuts down to 5. The mass is essentially doubled. Again, it's been done. So you want me to show you the video of this being done? Fine, if that's what you require. Now, if you don't accept these facts, it's not much I could do. So the whatever moron guy is asserting that if I have the same spring, okay, same exact spring, same compression, and I shoot the 5 cart, okay, and then I shoot the 10, his assertion is this one doesn't go away at 5 miles an hour. All right, we know that this one will go away at 10. We both, but maybe we can both agree on that. But this one, he says, doesn't go away at 5. He says the kinetic energy is conserved, so the momentum is not conserved. He says this goes away at 7 velocities. So these two can be equal kinetically. Okay, now, again, there's tons of examples demonstrating that isn't true. They've already done that. I can show the very people who are for your kinetic energy formula doing gravity experiments, where they lift something in gravity. And it's certainly not true that these numbers are realized, that half the mass takes twice as, 7 amount of energy to get up in the air. When no, half the mass takes half the energy to shoot. Now, it goes 4 times higher in the gravity, but when it comes back down, it's exactly the same amount of energy again. It just bounces on the spring exactly the same height. Half the mass, it does the same thing the other side does. So this number's silly. There's absolutely zero evidence of this 7. Oh, you can't see that. What a tragedy. Well, you still can't see it. Too bad. You can't see everything. Okay, too bad. There, I wrote it. 7. He says 7. Not 5. Not the rational, everybody knows they have to be equal. No, 7. So, I will play the physics girl video, and then you can tell me that you don't think she's right about her premises. So you can tell me exactly what I was saying, which is her video is accurate. And apparently you don't care if people make inaccurate videos on the internet, but you'll harass me. But you won't harass her. She can make inaccurate videos, and that's just fine. Okay, because she's physics girl, therefore it's okay. That's conventional physics. They can lie, tell the falsehoods, make up silly stories, and it's all okay. But if I make a mistake, no good. And again, I'm certainly asserting I haven't made any mistake in this case. All right, so he says it right here. Newton's second law says the two bodies will not have the same momentum. So same spring compression. he argues the same force ejects them, the same charge, and they won't have the same momentum. So somehow I can create extra momentum by putting heavy things on a spring now. So the heavier I put the thing on the spring, I can create some sort of synthetic extra momentum. Because now the light thing, again, only has the total momentum, which is 50. And because I'm doing, the heavier thing is going to be a 10 to 7. Now it's up to 70. So I get 70 momentums out of the heavy thing, and I'm going to get 50 momentum, 50 to 70. So somehow the little bullet, the lighter thing now, gets less momentum by some miracle. Complete nonsense, absolute garbage. All right, now let's get the... And then this moron says, wicked fatigue. Thank you. The video reminds me of someone saying, look, I have 11 fingers. You're the ones clearly making the logical and mathematical errors. You're the ones not having coherent numbers from 1 to 10. You're the ones who can't figure out the same spring can't make 70 momentums and then 50 momentums. And it's certainly not going to give more momentum to the heavier thing. Okay, he is talking complete nonsense. So no evidence of the nonsense. Again, just cheap, shitty little little weaselly arguments. No evidence provided. Not a single. They can't find a single link in the entire internet world, okay, to show where they're saying, yes, the experiment, we did it. And we made more momentum by putting heavy things in front of springs. We made more momentum by, shooting heavier bullets. Just too stupid. All right, so Pyrrho, again, can't capitalize anything. Just ugh. My answer is you don't say what happens in the collision. So, again, this has been based on, like I said, hundreds of other videos out there, and the very video he linked me to, the little 2-minute one, has the basic truth in it. Versus momentum versus kinetic energy not being the same. In that they put the little king crown on the thing that has twice as much momentum, and then they put the little king crown on the thing that has twice as much kinetic energy. And guess what? The crown on this consistent. 1 minute, one thing has more momentum, and the other thing, the thing with more momentum, somehow has less energy. It's in his own video, and he writes this tripe. Okay, my answer is you didn't say what happens in the collision. Yes, I did. I said we're going to double the mass of something, and that's all we're going to basically do. Something's traveling along at 5 miles an hour, and we're going to double its mass. And now, what happens to its velocity? And the fact is, its velocity just reduces in half. If I double its mass, I halve its velocity. That's the simple premise, and that halving means it lost half of its kinetic energy somehow. And yet, if I compress a spring with that very same cart that lost half its kinetic energy, I can get back 100% of my kinetic energy again just by putting the lighter cart in front of it. I mean, what the final velocities are. Okay, so my answer is you didn't say what happens in the collision, what the final velocities are. I mean, I've clearly stated what they are. I mean, it couldn't make it any more obvious. There's only 5s and 10s. So, I mean, it's quite obvious that it starts off 5 miles, and a weight of 5 masses, and I say it has a velocity of 10. And the final is, okay, it's got a mass of 10 and has a velocity of 5. So I clearly did exactly that. Too clearly. Couldn't be missed by anybody. Man, it's on the board. I mean, this 7's only here because the idiot said it, okay? I mean, that's the only reason why the 7's there. It was clear. You couldn't mistake this. There was only 5s and 10s on the board. Well, and the total number, sorry. I mean, the total numbers I used, I should have never used because I should have just said, yes, the momentum's 50. Okay, it's 50. I shouldn't have used 125. I was using numbers from another relationship. But I was just trying to show that the kinetic energy formula says you lose half the energy. And the momentum formula says you don't lose any of it. If you transferred it to the cars, you haven't lost any of it. And you can't say I lost it because it's like paint. It's either in the bucket or it's on the ground. And if there's none of the ground, then it's all in the bucket. If it's all in the bucket, it can't be on the ground. Oh, I mean, dumb. All right, anyway. final velocities are. The science does not claim anything you said was paradoxical. So there's just, the science doesn't claim it's paradoxical. It's paradoxical overtly. If what I said is true, it's paradoxical on its own. I don't have to make it paradoxical. The facts make it paradoxical. It's not paradoxical because, well, Gary said it's paradoxical. No, it's paradoxical because it can't happen. It's impossible to have this moronic scenario where, all right, so let's give the right numbers so moron Pyro can understand. Okay, let's give the actual numbers. All right, so we know, all right, so all we've done, let's just say we did this thing, all right? Let's just forget combining trains because that's apparently too complicated for you morons. So we didn't combine anything. So all we did was drop 5 masses into the train. So the train's rolling along, we drop 5 masses into it, and that means, you know, it started off just a 5, okay? So this is all we have. We have one train, okay? The train's moving. We drop 5 mass units into it. So now it's obviously a 10 mass train. And the question is, what happens to the velocity? The velocity was 10, and now it goes to 5. Now that's explicitly what Physics Girl is saying. So I'll play the damn video again because you people are just such liars. Okay, so if you want to say the physics is wrong, then say her physics is wrong. Not that I can't prove this is what happens in reality, because I can show you this experiment being done. So this is the absolute truth. This is what it does. Okay, so I double the mass, I cut the velocity in half. All right, so what does that mean momentum-wise? Yes, they're just reversing the numbers. So the momentum here was 50. The momentum here is 50. And if I take this cart and compress a spring with it, it'll be 50 units worth of momentum will be in the spring. And then if I release the spring with this cart, I'll have 50 units of momentum. So no matter what I do, I have 50 units of momentum. And I don't have any paint on the floor because I did it really efficiently. Okay. Now, if you want to say there has to be losses, it's okay with me. We'll just make this 4.8. And so then we'll say there's 48 units of momentum here, and then there'll be 46 units of momentum here. All right, so yes, we can do that. But if you have any capacity to think, you know, we don't need to do that. We don't need to account for those minor bits, all right, because you're talking about half of it missing. So using your formula, right, we square the velocity, so that's 100. And we have the mass, so that's 2.5. So 2.5 times 100, and we end up with 250. Yeah, 250. So that's the number we have to deal with. 250 for this one. So before I drop the weight, we had 250 joules. After I drop the weight, okay, so now we have a mass of 10, and we have that, so we have 5, and then we only have a velocity of 5, and that's 25. And you can see, oh, we only have 125 joules. So we lost, as stated in the videos over and over again, half. Oh, I wish blackboards were more cooperative. So we lost 1/2 of the, so we didn't lose, you know, 0.2. We didn't lose 0.2. No, we lost half the energy. 1/2 of the energy is gone. So somehow by dropping this, I lost 1/2 of the energy. 1/2. But if I take this heavy cart, you know, going 5 miles an hour, and I put a spring in front of it, compress the spring, lock the spring at that compression, and then reshoot this cart, miraculously, I'll get back the 250 number. Right? So I get, even though I lost the energy, somehow the energy will go into the spring. Somehow the spring will know I lost it and we want it back. And I put this cart in front of it without this weight in it, and I can get back all my joules again. So that's the paradox. How can you lose the energy and then somehow get it back by hitting something else? How does hitting something else get your energy back? That doesn't make any sense. Obviously, these numbers are just absolute garbage. The right answer is momentum. It's always the right answer. It works. It goes right through the equation very nicely. It's just silly to think that you can square velocity. That squaring of velocity makes any sense in any one of these circumstances, that there's any reason to think because I make something lighter, I give things more and more and more and more velocity, and therefore they have more and more and more energy. They don't have more energy. They're just lighter. They can look like they do, but they don't. Is there any way to make it? So the paradox is, I mean, you can't, you know, this bullshit, these bullshit evasions. Oh, do the F equals ma. How's that going to fix it? How's that fix this paradox? How does F equals ma fix this? This is the result of F equals ma. This is the consequence. You can't fix it. Again, if I use his numbers, the magic extra of, you know, I make the kinetic energy stay the same. That means that I would have to say that by dropping weight into this cart, I gained momentum. I added, you know, now I have 70 momentums in here, because it's really going to go 7 miles an hour. So that's the key thing you'll see in the physics girl video. She will admit there's no 7 miles an hour here. I don't put the extra weight and then keep a whole bunch of velocity. I have to lose the velocity. I can't gain velocity by dumping something in the cart. I mean, gain relative to the half number. Yes, it's less velocity than this, but it's going to be halved. It's not going to be 3/4. All right. So leave us play the video. And I mean, it's just like I said, when you have to go into this trivial detail, you know, and again, in the atmosphere where they've provided zero evidence, and all they provide is accusations that, no, somehow I said it wrong or I did it wrong. No, I didn't do anything wrong. Your physics doesn't work. All right, anyway. And science does not claim anything you said was paradoxical. So I'm going to show the paradox. I'll show it again, how it's just absolute nonsense, where physics girl says we 100% transferred the momentum, so all the energy went into the second train, you know, the bigger train, yet we lost half the energy. Okay, claim anything you say was part. You should describe the collision more clearly. I mean, come on. This is just not complicated enough for this baby talk. What do you think happens after they collide? I mean, just, it was stated what happens. The velocity drops in half if you double the mass. If you double the mass, you lose half your velocity. That's what happens. But somehow that means you lost half your energy. Which doesn't make any sense, because you have all of your momentum. Is the collision elastic? So here he's playing with this stupid elastic like this is a meaningful word. All there are is efficient and inefficient. Okay, elastic just really doesn't get to the core of anything. Elastic means if you want to have an inelastic collision, then you're going to have a collision where you can give it all away or you can keep it. Just the same scenario. It doesn't get to the core description of how well you transfer to one car to another car, and that's all that matters. How efficient is the transfer? And clearly, in all of these, the idea is very efficient. But it doesn't matter. They're just gonna keep throwing words out to dodge the subject, pretend there's no paradox when it's overt. I mean, it's pathetic. You can't argue with people this dishonest. All right, so she has just described basically the circumstance. So the car's going down the track, it hits, blah, 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 and they lock together, and now she's explaining how the momentum is conserved.
We ended up with half of the initial velocity, which makes sense because we said the two cars have equal masses, and we only had one of the masses moving at the start. So now you've got double the moving mass at the end. So they must be going half of the original speed if momentum is conserved.
There you go. So, I mean, it can't be any clearer. If you want to conserve the momentum, that's what has to happen. That's what does happen. Again, I could show you that actual experiment taking place. Little train going down the cart. They drop an extra one mass into it to double its mass, and it goes off at half the velocity. Fact, 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 fact. All right, so now she's going to do the let's look at the kinetic energy and see what a mess that is. Yeah.
And that's our basic inelastic collision problem solved using conservation of momentum. But what about conservation of energy? Is kinetic energy conserved in our system here? Surprisingly, no. Let's see why.
So that makes no sense, right? I mean, you do understand you can't, the only energy in this system is the motion of the cart. So if I make noises, or I vibrate tracks, or I kill something, pyrrho, if I run him the hell over, I have to take it out of my momentum. I can't run him over for free. I have to slow down because I did it. It's the price of doing it, is I have to pay for it with my momentum. So when I show up, I'm going to have less momentum. And somebody's going to say, what happened to your momentum? And I say, well, I had to kill pyrrho with it. But anyway, the point is I can't create any leakage to the environment and then claim I kept my momentum. You can't keep going 30 miles an hour if you're making friction, or you're making sounds, or you're disturbing other people, or doing something to the environment. You can't maintain your momentum. So she's already stated that she did transfer the momentum very efficiently. She doubled the cart's weight very efficiently, so all of the momentum was conserved. She said those words. And now she's going to explain that she lost half the energy, which is a nonsense, an overt nonsense.
By working out the math. Let's calculate the energies before and after the collision. Kinetic.
So we see it right here. So she did this part, right? So you can see this equation. P equals 2 kilograms times 12 meters per second equals 24. Equals, now she's reversing it, 4 times blah, 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 6. So instead of 2 times 12, now it's 4 and 6. So clearly it's just a reversal of the number. Okay, and it's the same amount, 24. 2 times 12 is the same as 4 times 6. Complete conservation of the momentum, that means complete transfer of the momentum. That means you can't have made any sounds or heated any tracks or smashed any anythings. Clearly, clearly, clearly. Again, so damn clear.
Energy.
So to the, the P whatever guy, it's right there in front of you. She didn't put some other number here, okay? The number is 6. It's half of this 12, okay? She didn't write down 8, okay? And she's not going to write down 8 here while she does the kinetic energy. She's going to admit the kinetic energy is way off.
Initial is just going to be 1/2 mv squared. Before the collision, we only have the first car moving, so the total energy is 1/2 m1 times v1 squared.
Right. The only energy in the experiment is in the car. All the energy. So any sound, any noises, anything has to come out of its energy. The initial energy has to be sacrificed for noises, sounds, vibrations, all of that stuff. It has to degrade the momentum initial,
which is going to be 1/2 times 2 kilograms times 12 meters per second squared, which works out to 144 joules. After the collision, so our final kinetic energy equals...
Right. So this is the car that the momentum says has exactly the same energy, and it's just inverted now. So you went from 5 mass and 10 velocity to 10 mass and 5 velocity. You just inverted the two numbers, which for MV means nothing, but for 1/2 MV squared means holy shit, you're going to get bigger difference. Numbers are not going to be anything like the same.
It's 1/2 mv squared. But my final mass is both masses together, which equals 4 kilograms. So this equals 1/2 times 4 kilograms. And then my final velocity squared, so my 6 meters per second squared. And that equals 7.
So let's understand, she's saying 6 meters per second squared. So she's saying 100% had to get in there. It was going 12, it's going 6 now. It's half. It's right there in her number.
72 joules. So we lost kinetic energy.
No, we didn't lose kinetic energy. You lost half the energy. Half. You lost a huge amount of energy. Where did it go? How do you account for it? Because technically your momentum can't be 6 meters per second if you lost some energy. If you lost some energy, you have to understand you can't possibly be going 6 meters per second with twice the mass. It can't happen. It's not possible. And if we are honest and we say we lost a little bit of energy in the transfer and we make that 5.8, it means that 72 goes down to 6 point something. It means it gets even worse loss of energy. It means you lost even more than half of the energy. So it doesn't fix your problem. It makes your problem worse. The simple truth is these are idiotic numbers. It doesn't work that way. And this is all frickin' moronic. So they don't explain the paradox. They don't explain how you can fix this at all. Show me where Physics Girl is missing something besides the retarded obvious part. That you can't possibly be going 6 meters per second after the collision, okay, as a practical matter because of these perfect, even if you did it perfectly, 6 is the best you can do. How could you lose energy to the environment, 50% of the energy, and you didn't make a sound, you didn't vibrate a track, you didn't heat anything, you didn't squish anything, you didn't kill any pyrrhos, you didn't do any of that, then how can you possibly lose half the energy? That's the paradox. You have no energy to lose. That is, you have no energy to squish anything with because all of it got to the train. All of the paint poured into the buckets. All of your velocity is still in there. It's now covering twice as much stuff. So it's all in there. None of it spilled. All the momentum made it. Do I have to keep saying it? I've said it already like 400 times. And they're actually going to defend the idea that you can conserve 100% of the momentum, the energy, and yet lose half of it. You can transfer it 100% completely. So again, it really is this childish. It's just like me having 2 buckets. Okay, here I am in front of a 10-year-old kid, and I'm going to tell their lie for you. Okay, and what I'm going to do is say to the kid, look, I have 2 buckets here. I have a gallon of paint in this bucket, and it's still in the gallon container. The paint, okay, and so what I'm going to do is I'm going to put it into this bigger bucket, okay, and all you have to understand is the bucket now weighs twice as much, and the paint is still weighs the same. Well, it can't weigh the same. It's going to weigh the same compared to the bucket. Well, the point is I'm going to lift up the paint and put it in the bigger bucket, okay, the gallon. And we're going to understand that means because it's heavier and it's got more paint. Okay, so I couldn't spill any. So I got it all into the bucket. And now I'm going to tell the kid, but I spilled half of it. Half of it's gone somewhere. I lost half of the energy somewhere. I lost half of something somewhere. I lost half of anything anywhere. How can I possibly have lost anything when all I did was transfer it? I guess the better example is I put the gallon of paint in the bucket, and then I put that bucket inside of another bucket to really demonstrate how I can't have lost any paint. I can't have spilled anything. Maybe just the water example is better, right? So velocity is water, right? And I have a certain amount of water in a certain size bucket. It goes to a certain height, right? It's that simple. So I have a gallon worth of water in the bucket, and it goes to a certain height on the bucket. And now I take a bucket that has twice the volume. So now when I pour the same gallon in it, it'll read lower. And I pour all the water into the second big bucket. The simple argument is the kid can watch me get all the water into the second bucket, and it'll even read the right number, half. It'll figure just right. Half the volume, twice the volume. I pour the water in, it only fills half as high. Everything's working out just fine. And then I try to tell him, but I spilled half of it. That's a paradox. You can't pour all the water into the other bigger bucket and then say, but I spilled half of it. Yeah, that's it. And they're not going to explain that. They're not going to point out how physics girl's wrong. They're not going to do any of this. They're just going to call me names and run from the truth in a despicable manner. That's all this is. It's despicable. It's despicable behavior. You're all on the ash heap of despicable. You're despicables. I mean, I'm going to go Hillary Clinton to call you names because that's exactly what you are. You're deplorable, despicable. You're horrible human beings who have no integrity. You have no honesty. You won't admit when, okay, yeah, that doesn't make any sense. It can't happen. That what she just said can't possibly happen. You can't pour the paint into a bucket twice the size, fill it half as full, and then say, I lost half the paint. That's it. Like I said, there's no point. All I can do is be a decent person and logically attempt to make you understand something, and make it as simple and as honest as I can make it. I can't do I can't do your side for you. Apparently, you are just that. You're just despicable, lying sacks of shit who wish to insult me for being right. You don't like that I'm right, and that's all it comes down to. You don't like it. And so you're going to pretend I'm wrong because you are petty, shitty, crappy, low character scum. And that's it. That's all. That's the only rational perspective here. Scum. Yeah, you're scum. Lying, shitty, scum. This has been a DraftScience video presentation. Come back and see us, okay?